Welcome back. In this video, we are going to solve problem 13-6 that is taken from chapter number 13, Buckling of Columns, and book name is Mechanics of Material by R.C. Hibbeler, 9th edition. So statement is a rod made from polyurethane has stress strain diagram in compression as shown. If the rod is pinned at its top and fixed at its base and is 37-inch long, determine its smallest diameter so it does not fail from elastic buckling. So this is stress strain diagram for polyurethane under stress under compression having 8 ksi load stress and 0.03 strain at this load clear, that is under the proportional limit. So you have to determine the smallest diameter so that it does not fail from elastic buckling. So let's start with the solution. As we know that Euler formula for central axial load is given by P critical is equal to pi square EI divided by effective length square. Clear? And we will find this E by using this stress strain diagram. So I can write it from stress strain diagram. As we know that during a proportional limit, we know that stress is equal to E into strain, and from here E will be equal to stress divided by strain. So in proportional limit, stress is 8 ksi and strain is 0.03. So 8 ksi, so 8 into 10 raised to power 3 divided by 0.003. So I will write 8 multiplied by 1000 divided by 0.003 is 2.666 into 10 raised to power 6 psi. So E is equal to 2.667 into 10 raised to power 6 psi. Now we know that for circular rod, moment of inertia I is equal to pi by 4 r power 4, where diameter is given. So we know that diameter is equal to 2r. So r is equal to d divided by 2, because we are interested to find out diameter. So we can just plug it in this formula. So it will be pi by 4 multiplied by d divided by 2 power 4. Okay. Now what is effective length? So we know that effective length is equal to k multiplied by L, where k is a factor that will be taken from the book, and you can see in question we have been given that one of the end is pin and other is fixed. So this is pin and this is fixed. So for that, effective length is 0.7 L. It means that k is equal to 0.7. So I can write it as k is 0.7 and L is how much? L is 37 inch. So 37. Okay. Now you have all the values. So plug it in this formula that P critical is equal to pi square multiplied by E is 2.667 into 10 raised to power 6 psi. Clear? Divide by P. Sorry, not. I have not to write the unit over here. So 2.667 into 10 raised to power 6, and I is pi by 4 into d divided by 2 whole power 4 divided by effective length, which is 0.7 multiplied by 37 whole square. As we know that P critical is maximum load or critical load that should not exceed the yield strength or proportional limit. So we will take this P critical is equal to critical stress multiplied by area. As we know that, I will write it over here that critical stress is equal to critical load divided by area. So P critical is equal to critical stress into area. So critical stress under a proportional limit is 8 ksi, so 8 into 10 raised to power 3 multiplied by area is pi by 4 or pi by 2 sorry pi by 4 d square, pi by 4 d square. You can also write it as 8 into 10 raised to power 3 multiplied by pi d divided by 2 whole square. Okay, this is P critical. Let this is equation number 1 and this is equation number 2. So what we will do is that compare equation 1 and 2. So we will get 8 multiplied by 10 raised to power 3 multiplied by pi multiplied by d divided by 2 whole square is equal to pi square into 2.667 into 10 raised to power 6 multiplied by pi by 4 multiplied by d divided by 2 whole power 4 divided by 0.7 into 0.7 square multiplied by 37 square. Okay, this pi will cancel with this pi. Clear? This d by 2 will cut with this, so here we will left with power 2. So I can write it as 8 multiplied by 10 raised to power 3 multiplied by 0.7 square multiplied by 37 square divide by this pi square will come down. So pi square multiplied by 2.667 into 10 raised to power 6 is equal to, okay, this 4 will be in here in denominator and it will be multiply it with here. Similarly d over 2, here we will left with d square over 4 because this term is d divided by 2 whole square will give you d square over 4. So again if you multiply 4 on both sides, so you will get d square will be equal to 4 multiplied by 4 multiplied by 8 into 10 raised to power 3 multiplied by 0.7 square multiplied by 37 square divided by pi square 2.77667 into 10 raised to power 6. We will calculate it. So I will write 4 multiplied by 4 multiplied by 8 multiplied by 1000 multiplied by 0.7 square multiplied by 37 square will give you this divide by 3.1417 square multiplied by 2.667 multiplied by 10 raised to power 6. Okay, that is d square is equal to 3.261. So from here d will be equal to under the root 3.261. So what I will do is that square root of answer will give you 1.806. So d is equal to 1.806 inch, and if you round off it, so d is equal to 1.81 inch. So this is the diameter of nylon. This is the diameter of polyurethane rod that will carry this load shown in proportional limit and will not buckle or fail from elastic buckling. So this was all about problem 13-6. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.